Hello and welcome to our webinar today about power quality analysis in public and industrial grids. My name is Thomas Schwarz. I'm a power quality engineer at Eberle, and I'm going to talk about experiences, applications, and I will give you a future outlook about certain topics today. Last webinar, we had many questions, and many questions, they were asking about certain topics we could possibly talk about. And that's why I'm going to talk about several topics today that people asked for. So today the webinar is, as always, for you, and I will encourage you, feel free to type your questions into the chat, and we will definitely answer every single question and get back to you as soon as possible after our webinar. So that leads me to the agenda for today. As I said, many topics people from the last webinar asked for. So first of all, I am going to start and repeat a few things from the last time about power quality standards, especially the standard IEC 61000-2-4 for industrial grids, because that is the newest standard that was published last summer. And I'm going to talk about how to change the evaluation of your recorded data afterwards. So if you already have the data, and then you can change the norm evaluation after the recording is finished. So this is a very unique feature with PQMobil and the PQ boxes. I will focus on that today. Secondly, many people asked for, well, I want to evaluate electronic devices I test in the laboratory, and I want to see whether they meet the criteria for current harmonic emissions. And for this topic, there are two important standards, the IEC 61000-3-2 and -12. I'm going to talk about that in a few minutes and tell you some practical experiences, and I will always show measurement data and the application in PQMobil for each point on the agenda. So very practical session today. Then I'm going to talk about extreme values and the continuous reading. So what does the 10-minute average value tell me compared to a peak value, for example, or a 10 millisecond or 200 millisecond extreme value? Later on, I will continue with harmonics, interharmonics, supraharmonics. So what's more or less the difference and what is the best way to evaluate them? There are different types of display within PQMobil, and I will show you that in detail. And last but not least, I'm going to talk about remotely accessing the PQ boxes. So this is something that more and more customers are asking us. How does it work? What types of communication do I have? So certain interfaces and applications with the app, for example, or PQMobil software. I'm going to talk about that at the end. So, and I will always try to encourage you again, feel free to type your questions or comments in the chat function, and we will get back to you. So first, I'm going to start with the PQ standards and how to change the evaluation method after the recording. First of all, more and more standards worldwide, they extend their limit range into higher frequencies. So high frequencies not the 50 hertz and 60 hertz. That doesn't mean the nominal frequency in our electricity grid, but the interference frequency. So we are talking about harmonics and supraharmonics. And the first standard that closed the gap between 9 and 150 kilohertz was the IEC 61000-2-2 standard back in 2018. So this was the first one that came up with limit values up to 150 kilohertz. The widespread EN 50-160 in Europe kind of got a similar approach. They extended not their own limit values, but they said that if you experience interferences in the high frequency range, we do not have our own limit values, but please have a look at the IEC 61000-2-2. This is the IEC EMC standard for public grids. And this covers the frequency range up to 150 kilohertz. So the EN 50-160 from 2021, they refer to the limit values from the IEC standard. And finally, for industrial grids, last summer, the IEC 61000-2-4 edition 3, after 22 years after edition 2 was released, they came up with edition 3, and now they define their own limit values from 2 to 150 kilohertz as well. And a very important thing about that is they demand 200 hertz bands. So this is new because the other standards, they didn't mention these 200 hertz bands in detail, that specific, but the 2-4 standard does. And also the IEC 61000-4-30, which more or less defines the measuring technique for Class A devices, also uses the 200 hertz bands. And the PQ-Box 300 can do that. When I focus on the IEC 61000-2-4 from 2024, edition 3, so like I said, this is for industrial applications. So not for the public grid, but for the private grid for industrial applications. So inside your property or manufacturing halls, etc. This covers all voltages up to 35 kilovolts. But what's new in this standard? Well, something that is new is the previously highest order for the THD, the total harmonic distortion, was up to the 50th order. Now it's up to the 40th order. So they kind of adapted to the other standards worldwide, which also go up to the 40th order for the total harmonic distortion. Secondly, the second edition had 3 classes. So class 1 for very sensitive devices, class 2 for normal devices that were also connected to the public grid, and class 3 for heavy industry, so welding machines and very big machinery that also produces high emissions. The edition 3 has 5 classes by now. So class 1 is the same as before. Class 2L, L stands for legacy. It's the same as in the previous edition. And what's new? class 2A and B. Now they distinguish between office environment and light industry environment. In most of the cases, the limit values are similar, but not every limit value. And as in the previous edition, class 3 for heavy industry. And I'm going to talk about these on the next slide. But first, of course, after 22 years, our power grid changed a little bit. The technologies changed, and so the limit values changed as well. So I have an example prepared for you to compare the limit values from edition 2 against edition 3. And some new limit values appeared, like the PVHD, the partial wave harmonic distortion. I will come to that in a few minutes. And very new, in the past, they defined the limit values for the values over 100% of the time. New in this standard, edition 3, is that for many measured variables, they define the limit values only for the 95% quantiles, like the EN5160 does. And as mentioned on the previous slide, the compatibility levels go up to 150 kilohertz now. So this is the most important fact, because the 150 kilohertz was not covered in this standard before. So here is an example between the limit values of certain harmonics. So, like mentioned before, back in 2002, edition 2, we had 3 different classes, class 1, 2, and 3. Now we got 5 classes, 1, 2 legacy, 2A for office applications, 2B for light industry, and 3 for heavy industry. And here I brought up 2 harmonics that were also previously changed in the EN5160, for example, back in 2019 and 20. So these are the limit values of the 15th harmonic for the voltage distortion for the different classes. From 2L, 2A, and B, I took the values from the previously mentioned class 2, because these classes didn't exist before. So 0.4% of the nominal voltage was allowed for the 15th harmonic. Now, in 2024, for example, these are the new limit values for the 15th harmonic of the voltage. So they increased slightly. The same applies to the harmonic of the 21st order, for example. Let's say in class 3, for example, we got 1.75%, and now we got 3.1%. So this is because many more electronic devices, they produce distortions, and the 15th and the 21st harmonic, they are more visible in our industrial grid by now. So, and that's why the limit values, they adapted to the new situation. And as in many other standards, these limit values were increased. So you, as a customer or user, do not have to worry about all the details, which limit value changed, which was increased, or which was lowered. You really don't have to care about that, because we do. We take care of all the standards worldwide. My colleague Jürgen Blum, for example, he is a board member of some standards, so he knows where the standards tend to change or extend limit values, and the standards are continuously maintained with our free software PQ-Mobil. So you are always up to date with the standards. As soon as a new standard is published, it won't take very long, and a new version of PQ-Mobil will be released and published, and then you can download it. So you are up to date as long as you're willing to get a free update once or twice a year. So if you do that, you are always up to date with the modern standards. So these limit values are important when it comes to creating a power quality report. So how to do that? So this is now how to change the evaluation standard afterwards. That's today's procedure, how you can quickly and easily generate a power quality report. So after you finished your recording, you can import the measurement data from the PQ-Box. When the measurement data is on your PC, you can open the measurement file. PQ-Mobil automatically asks you what period you want to open. If you have a measurement for over 2, 3, or 4 weeks, for example, you can select whether you want to open all measurement data. That's what I usually recommend, to see everything that was going on, or you can limit the period to a day, a week, or a month if you want. You can change this afterwards in PQ-Mobil as well. So afterwards, after opening the measurement data, you can choose whether you want to go with the default settings or whether you want to evaluate the data against industrial standards or standards for the public grid, and so on and so on. So PQ-Mobil offers you a range of different standards worldwide. So you can choose whatever you want and then simply click on the non-evaluation button, and PQ-Mobil provides a report. The first step, you see it in the software, and if you click on the printer icon, you can export this report as a PDF. And I'm going to show you now live in PQ-Mobil how to change everything and the evaluation method, and to change the settings, and later on the evaluation period as well. So let's jump right into PQ-Mobil. So now you see my screen, and I will open a measurement file. And here, so this is only 4 days and 20 hours long, so less than a week in this case. So I cannot select 1 week, 3 weeks, or 4 weeks. So, but I go for all and confirm with OK. So first of all, I will check my report settings. Usually, PQ-Mobil, if you haven't changed any settings, goes with the default settings. And I go to Setup, Report Settings, wrong window, and here we go. And this is the default setting. By default, PQ-Mobil, if I click on Default Settings, we go with the EN5160, and the values that are not covered in the 5160 will be completed with the values from 61000-2-2, as both are almost the same values, and they're both for public grids. So with this evaluation, I can click on OK, and this button, at the very top, Norm Evaluation, with one click, I will get an overview. And now I see, okay, there is a field with supraharmonics, and if I click on that, I will see the values of the supraharmonics. So another tab opens within the report. On the very left, there was my overview. Then I get some details. I will just real quick jump into that. Then the harmonics, supraharmonics up to 9 kilohertz, and the supraharmonics up to 150 kilohertz. Don't get confused with the display in decibel microvolts. This is from the standard, because the standards, they go with limit values with this unit, decibel microvolts, not volts. It's a logarithmic scale. These are applied for frequencies from 9 kilohertz to 150 kilohertz. I will see the limit line, the green one, up to 150 kilohertz. I can also go for a table view, and if there were any violations, the limits are in this in red. I can also go for the heat map or a 3D model if I want. So that's what I see here. But the thing I actually wanted to show you is now I opened the whole data, 4 days and 20 minutes, 4 days and 20 hours, and I'm going to change the standard I want to evaluate the data against. So I go to setup, report settings, and now I can load a different standard. So I go to the IEC 61000-2-4 for industrial applications, because this was a measurement inside an industrial application. So, and here I see the old classes 1, 2, 3 as well as the new. So you have the chance to evaluate with both versions. We didn't delete the old ones, so you always have both. So I go, for example, so this was an office light industry. I go for this standard, for example, 2B for light industry, this category, class 2B. I will open, and PQMobil automatically adjusts the settings. I confirm with OK, and now I can do the norm evaluation again. So I open this again, new window, and here at the very top I see in the title of the tab, this is IEC 61000-2-4, and previously it was the default setting. So in here, I can always click on flicker, supraharmonics, and so on, and check the values. So as you see, these are slightly different. The measurement data is the same, but the limit values, they change a little bit. You see the green line, it's different. And it's even more different if I opened the old standard. So I will go to the report setting again, and just as an example, I will load the old class 2. I click on open, and what immediately stands out is here is this tick for 9 to 20-150 kilohertz is missing because the old standard did not cover frequencies above 9 kilohertz. I click on OK, and I do the norm evaluation again. So third approach, and now I see, well, supraharmonics, no problem, because I only evaluate up to 9 kilohertz. So everything above 9 kilohertz won't be considered for evaluation. So that's the big difference. And maybe you saw these bars or columns for long-term flicker. Here we got a red cross. This is in the new version of PQMobil and indicates well, the limit values were exceeded. So this information tab gives me a legend, and I see, okay, a long-term flicker does not comply with the limit values. Well, if you remember, this is, for example, one detail that has to do with the 95% quantiles. So the previous edition 2, they did not compare anything against quantiles. The new edition does. So if you got only a few measuring points that are above the limit values, the old version considered it as a no-go. The new version, I go to the overview, deals with a 95% quantile, and so it's not a problem. There's no red cross over here, and these values now comply with the limit values. What exactly a 95% quantile is, I explained this in one of our videos. I will come to that in a few minutes. So with the report settings, I will deal with that in a whole free video tutorial, and I'll explain in detail what a 95% quantile is, for example. But most important, you can change the standard afterwards. A few years ago, we changed the philosophy because in the past you had to tell the PQ-Box before the recording which standard to apply. So before the measurement, you have to choose whether you want to go with a -2-4 for industrial applications or -2-2 for public grids, for example. And changing the method afterwards was not possible. So if you got the wrong standard, the wrong settings, it was not possible in the past. We changed this, and now you can change your evaluation method afterwards as you want. If you have any questions or comments, feel free to use the chat function. So I was talking about the harmonics now, and oops. Now I want to talk about current harmonics. So the second point on the agenda, because voltage harmonics, they are covered by power quality standards for the public and industrial grid. Current harmonics are other standards deal with current harmonics. So there are several international standards that deal with the current harmonics. The most popular among them are the IEC 61000-3-2. This standard covers the limits for current harmonic emissions for equipment rated 16 amps or less per phase. So for example, a washing machine, a dishwasher, a tumble dryer, so normal household devices usually. If we go bigger, we go to the -3-12 standard. This covers equipment with an input current from 16 to 75 amps per phase. So this is, for example, for if you got big AC cooling systems on the roof of a skyscraper or any building, they consume more energy or more electrical energy, and as well as big machinery, robots, and so on and so on. So this is for equipment from 16 to 75 amps. If you go bigger and have very, very large machines, you usually go and contact your local utilities, and then you negotiate and find contracts and write everything down, and they usually give you some details and tell you how to connect and what limits to pay attention to for connecting your big machine. So with your local utility or grid operator, you do that for extremely large machines. And then there's -3-3. This covers the distortion in terms of voltage changes and fluctuations and flicker, also for the equipment which is rated 16 amps per phase or less. Dealing with these standards is difficult and challenging sometimes because you got many tables in there and many exceptions and special conditions and so on and so on. So if you have the standard, it's not that easy to work with, but it's possible, but it's even easier if you just go with PQMobil. So let's say this example, all the limit values are covered within PQMobil already. So you can do these lab tests for electronic equipment with PQMobil and the PQ boxes as well. So let's say, for example, Harmonics of the second order, they're allowed to have an emission of 1.08 amps per phase. And you will find this as well in PQMobil. So second order, 1.08 amps. And this is what I'm going to show you now to see where to find these settings and evaluation. So I jump right into PQMobil again, and I will open another measurement file. So I'm going for a water pump. So this was a customer. The measurement was 11 days. Here for a better visibility, I close all existing windows. So now we start from scratch. This is the measurement I opened, a water pump. So a customer wanted to check whether the water pump he installed meets the criteria of the standard. So we measured the current, of course, as well as the voltage and current. And now we got, oh, I don't hear anything anymore. I hope you can hear me. And so I hope my sound is still on. And now I can change, or I can open something at the very top, current harmonics. So if I open this tab, PQMobil opens the current harmonic evaluation. First of all, I see, well, there are high emissions on the 5th and 7th order, 11th and 12th order, and so on and so on. So this is very typical for a B6 rectifier, so a classic rectifier. But these values are in amps. I do not see any limit lines. Well, that's because the visualization is in amps. If I change this to another display format, for example, in percent of the fundamental oscillation of the 50 Hertz network, in this case, the display changes to, for example, 84%, but still no limit value. I can also change this to a nominal value I can set individually, because some standards, they require for the evaluation a nominal value of the machine, for example. I can change this in here, and if I type in 50, for example, now we are at 28%. If I go with 50, PQMobil calculates everything new and now the limit, not the limits, but the values in percent of the nominal voltage, they change, of course. So you can play around and do some experiments with that. Now I go to in percent of the limit, but which limit? So for the limit, I have different opportunities. So we can compare the values of the measurement data against different limit values. So let's start, for example, with the IC 61000-3-2. So class A would be normal household devices, washing machines, tumble dryers, but we do have a pump, and this pump is heavy duty. So this pump is actually above the 16 amps. So I do know that. So I go, for example, for the 3-12 and open this file. I can load the values. Oh, sorry. I can apply these with confirming with OK. And I can always, if I have special conditions or an individual contract and individual limit values, I can adjust every single limit value in here up to 9 kilohertz. So this is possible. For example, the third harmonic, 25 amps, I can set an individual limit value and go as I wish for each individual harmonic or interharmonic. So I confirm with OK. And now the evaluation changes. I see, okay, I'm still above the limit values. So I can adjust and figure out what do I need to change, or the limit values, which limit values have to be changed or to get below the limit lines. So I can play around with this as well. So I can change this as I wish. I can open another standard as well if I want. Go with OK. And now, for example, I only evaluate up to the 21st harmonic. All the others disappeared. So I can do many adjustments within the individual limit values as well with the limit values from our standards. So when talking about current distortion, there are other values as well. There's a total harmonic distortion for the current in percent, and there is also a total harmonic distortion of the current in amps. I will focus on these two in a minute, but I also will show that there are more measured variables as well in different standards. So for example, the industrial standard 61000-2-4, they also included the partial weighted harmonic distortion as well. So this considers, for example, harmonics from the 14th order up to the 40th order. And each individual harmonic is multiplied with its order. So this is the n. So the higher the harmonic order, the more it affects my value. Because the higher the harmonics, it's possible the more harm they could cause. And then there's, for example, another exotic value like the PHC, the partial odd harmonic current. This only considers odd harmonics from the order of 21 to 39, for example. In some cases, this also has to be considered. Very important, if you open harmonics and display harmonics in the level time, in the timing diagram, for example, and see the THD over a week or the 15th harmonic over a week, you can select whether you want to see the values in percent, for example, in percent of the fundamental oscillation, or in percent of a nominal voltage. Then you can change the nominal, not voltage, the nominal value, of course, in amps. And you can change the nominal value in these settings in the harmonic view as well. So you can change the view in here in the settings. And I'm going to show one example and with another value. So I open, there's a solar inverter. I will close all windows, and now I will go to the permanent record and I will check the current, the true RMS current over time. So what I see is that the 10-minute average value, because the measuring interval is 600 seconds, which corresponds to 10 minutes, is around 112, 113 amps during the day. So we are at around noon in here, and overnight there is no current. So that's what I see in here. The recording lasted 4 days and 1 hour. And now I'm going to check the THD of my current. I open this and I see, whoa, this is bad on first glance, only on first glance. So if I see, well, okay, at night, so in the morning and in the evening, the distortion is really, really bad, but should I do something against that? How bad is it really? Well, now you have to consider that the value in percent is in percent of the fundamental. So if I check both values, the THD and the true RMS value, I see, okay. So I got distortions over here at around 100%, but the current was quite low. And now, last but not least, to see how high was the actual harmonic current, I can also go for the THD in amps. So this is very useful. I open this and now I see, okay, what previously was seen as, well, around 100% and very high levels at night in percent of the nominal not voltage, current, is actually not that bad, because in amps we got around 5 amps, and during the day we got around 114 amps. But the THD during the day is not as bad. So this time I open all 3 values, 1, 2, 3. So I will actually start with the current on top, the THD and the THD in amps. I open a timing diagram and I will just go with phase 1 to see it a bit better. So the THD in percent is very high during the night, but the current that flows is very low during the night. During the day, my THDI is not that bad. It's less than 10%. And the actual current that flows is way higher than 100 amps. So this is something you have to take into consideration when having a look at the total harmonic distortion of currents. Now I'm going to talk about the peak values a little bit in short. So for example, so the extreme values, for example, when to use the RMS value or the 200 millisecond value or 10 millisecond value or even the peak values, when to use which of them and what's the actual information I get out of them. So I jump right into PQMobil again and open another measurement file. So I go, where's the peak? Yep. I will close all windows. And now, so this is an office building that also has some laboratories. I know that they switch on the light in the building, and in these laboratories they have racks with a lot of measuring equipment, and they have one central switch to turn on all of the equipment in the whole room. So first what I'm going to check is the true RMS value of the current. I open the timing diagram, and now I see the true RMS value of the current. I see peaks. I hold down the shift key and do a left click and see, well, peaks at around 56 amps. So please consider this is a 10-minute average value. So 10-minute average values, they are good when it comes to the thermal condition of your conductors. So if you want to see thermal overloads, they don't happen with short peaks, but if you continuously stress the conductors with too high values that are too high, then they get warmer and warmer and may get damaged. I can also check the maximum values. The maximum values, we have different maximum values. We have the 200 millisecond value. If I open this, so there are 5 of them per second, and it covers 10 cycles in the 50 Hertz net or 12 cycles in the 60 Hertz network. And this is way higher. Well, way higher. It's a bit higher than the 56 amps because we only have a look at a 200 millisecond time window instead of 10 minutes. And these values are a bit higher. Then there's a 10 millisecond value as well. So a half cycle value. I explain what a half cycle value is in one of our videos, so the trigger video, our free video tutorials. And so these are even higher again. So when switching on everything, I can see, I zoom in here a little bit. So, and I see, okay, the first peak every day is around, 565 in the morning. Here it's at around 5:49. So every day at around 6 o'clock, they turn something on, usually the light. And that causes some peaks. I see the 10 millisecond peak in here. And these values are higher than the 200 millisecond peaks. Of course, because I get far more details with the 10 milliseconds. So this is something you have to be aware of. Many manufacturers, they only come up with a 200 millisecond extreme value, minimum or maximum. And this is different from the 10 millisecond values. So you get more extreme of the extreme values from the 10 millisecond values. So you cannot compare these because they are not equal. The 10 millisecond value, if you want to investigate some faults, for example, and want to see, okay, what causes these faults, or are there any special conditions in my network, any peaks, the 10 millisecond value is way more interesting. And even higher values can be seen with the peak value, because the peak value, they even go with a sampling point. So if you go with a sinusoidal wave, you have a minimum and a maximum, and the highest sampling points are captured with the peak value. This is very interesting when, for example, you or the customer experience distortion problems with uninterruptible power supply systems. So a UPS system, if load draws these currents, the UPS system, if it's online, they have to deliver all that current, and this stresses the electronics inside. So you have to be aware of the high peak values, especially with the UPS systems. So, and here we got total different values again. So now we are in the range of 290 or 305 amps compared to the 100 amps 10 millisecond value, or 60 amps 200 millisecond value, and 56 amp 10-minute value. So different time ranges. The shorter the time range, or even go to the sampling point, the higher and more extreme the values are. I will talk about the measurement data in our new video, measurement data, which is also available on our website, for example. And I'm going to talk about different types of how to display the measurement data, where to find the right data, and which settings make it easier for me to evaluate the data. I'm going to talk about the measuring interval I previously mentioned with the 600 seconds, for example, UTC synchronized data. What is this? You will find the answer in the video, and so on. So data export, extreme values, display of harmonics, everything about measurement data is covered in this free video. Where to find the video? So you can go to our website, a-eberle.com, go to service, knowledge, training videos, or you can follow the link, or simply go to a-eberle.com/PQBox videos, separated with a dash. And even easier, you can open PQMobil. I will jump right into that one more time. Click on the help button and check out the video tutorials. PQMobil opens a window and automatically opens the web browser, and you will have access to the videos, all the videos that are available. And you can also go on YouTube and just simply search for PQ-Box. So the last topic I'm going to talk about is how to change the evaluation period in my measurement data. So when is this useful? Let's assume you started a recording and then you check other locations or do something different, talk to the machine operator. You set everything up, the recording is running, then you close the door of the cabinet, for example, where the PQ box is inside. And when closing the door, you hear some clack. And so, okay, what was this? You open the door and see, oh no, the voltage probe, for example, of phase 1, 2, or 3 dropped because it was not connected that good. So, well, is my measurement file useless now? No, it is not. And I will show you why. I'm going to open the next measurement. And so this is, for example, something. In this case, the voltage probe did not drop, but the thing I'm going to show you, the tools are also good for this use. In this case, this would be a second application. Let's assume, well, the story is a customer installed an active filter and then he wanted to see the difference between the active filter is not turned on versus the active filter is turned on. So I can see the whole measurement file, 3 hours long. I go to norm evaluation and check the values. So I, for example, want to check, oh, superharmonics, harmonics, and THD is bad. Well, I click on the THD and see the timing diagram. Well, it was bad at the beginning of the measurement of the recording, and then it dropped. And at the end, it was good. So now, if you want to present a report to your customer or for yourself, you can simply change the evaluation period. At the very bottom, at overview data, there are 2 bars, 2 orange bars at the very bottom. I can just, with holding down the left mouse button, I can easily change the evaluation period. Now this should be just a very straightforward way. I just reduce the time I want to evaluate. Then I click on the refresh button. This is very important. And then I will start the norm evaluation again. So norm evaluation again. And I see, well, the harmonic levels are bad. I only see the high levels, about 9%. If I want to see the limit value, I can add the limit value as well with limit lines. Click on OK, and I see the limit value is 8%. So this is very typical for many standards. Everything looks bad. Well, at the beginning, now I change the evaluation period and shift it to the right side, to the end of the measurement, and click on refresh. And now I see only this data is evaluated. I click on norm evaluation again, and now it looks different. Everything looks good. So if I click on here, now the THD dropped to 3%, for example. And now I can compare all the values. I can export this to a PDF and say, well, old versus new, for example. So this is very, very easy. And a little spoiler for the next version of PQMobil 8. Now, if you want to share not only the PDF document, for example, but if the customer or colleagues are working with PQMobil and PQ boxes as well, you can share the measurement files as well. You don't have to share the whole measuring file. You can separate it into 2, for example. So I changed the evaluation period in here. And if I click on this one in WinPQ-Mobil 8, I open the data converter, and this is new. I can change the duration. So I can clip from both ends, from the start and the end, the measuring period, and change how it should look like. And now I can export a new measuring file, for example, new active filter on, and I can export this into a new measuring file. I can do the same with the other measuring evaluation period. If I move it to the left side, click on the refresh button, and then click on the data converter symbol, and now it automatically adapts the times I set here. So this will be new in WinPQ-Mobil 8 for sharing measurement data, for example. Very convenient. Last but not least, I will talk about how to remotely access the PQ-Box. So the PQ-Box, all the PQ-Boxes, they have different interfaces. So let's connect several PQ-Boxes to my laptop. So I go in this example with a direct connection. This means from device to device. The easiest way is, well, take the USB cable that comes with the PQ-Box, connect it to your laptop, connect it to the PQ-Box, run WinPQ-Mobil, and it automatically detects the PQ-Box. The cable has a length of approximately 2 meters, so you're limited to a certain range. Of course, you can purchase a longer cable, but USB cables, yeah, maybe 5 meters or so, it's possible. If you have longer distances, well, then you should go with an Ethernet cable. You can also connect this to the PQ-Box 150, 200 or 300, because the PQ-Box 50 does not have an Ethernet RJ45 socket, but all the others do have. And then you can go either directly into your laptop or with a USB to Ethernet adapter into your laptop. So this is also possible with the TCP/IP protocol. And you can always go wireless as well. Therefore, the PQ-Box needs the Wi-Fi package. The PQ-Box 50 always comes with Wi-Fi. The higher models, it's optional because they also do have an Ethernet socket, but you can either connect to the PQ-Box hotspot. So the PQ-Box 50, for example, or 150, doesn't matter, generates a Wi-Fi hotspot, and then you can connect with your laptop to the PQ-Box. Open WinPQ-Mobil, then you have to set up the TCP/IP connection with the connection manager, and off you go. You will find all this in the user manual as well. So this is a direct connection from one device to the other device. If you have something in between your computer and the PQ-Box, let's say a router, for example, if you are connected to a big network in your office, then you always have a router and switches, and you can access PQ-Boxes that are in the same network as well. You can connect them with Ethernet cables, for example, or with Wi-Fi as well, and then access the PQ-Boxes remotely. If you have internet access, you can always go via your mobile network to a different location of the PQ-Box when, for example, you use an LTE router. And to this LTE router, maybe there is a PQ-Box connected via Ethernet cable or Wi-Fi. Then you can access the PQ-Boxes as well. I would always recommend secure your way of communication via the mobile network with a secure VPN. tunnel. So an encrypted tunnel, you can go with different technologies. In our accessories catalog, we provide a very, very secure router, which has a highly encrypted tunnel and is very easy to access remote devices. What you always have to consider is that when working with network, you find the connection manager within PQ-Mobil, and there's also a very similar, very easy to understand how to document on our website within the download section. So I give you one example, a very practical example, when you can also use the PQ-Box app and why. So this also is a remote connection via Wi-Fi. You can use the free app, PQ-Box app. You can find this in the Google Play Store for Android devices or in the Apple App Store for iOS. It works with tablets and smartphones. You can parameterize your PQ-Box, set the measuring interval, the nominal voltage, and so on and so on. You can see live measurement data. So you can check with the Harmonics, the oscilloscope, you can check the connection with the phasor diagram, for example, and you can start a recording remotely. And always you can check the installation. Is the phase sequence correct? Does phase 1 of the current match phase 1 of the voltage? And here I give you one very practical example when to use it and why to use it. So let's assume you install the PQ-Box in a danger zone. There is a voltage. You can access the dangerous voltage. The whole environment is dangerous. So please take care. Only skilled people should perform the installation. If you work under voltage, it's even more dangerous. Sometimes you cannot shut down the region where you want to measure. So then it's even more important. Take care of yourself, use the right equipment, install the PQ-Box, and then after installing everything, you can go away, step back from the dangerous area and check the installation with your smartphone. You can connect via Wi-Fi and see the values as I expect them. For example, 230 volts. Are the phase angles correct? Did I connect the current probes correctly? And check everything, like the phase sequence. Same colored arrows always point in the same or almost the same direction. And then if everything is fine, you can finally start the recording, also with the app. So this is it's a safety feature, so to say, because you reduce the time you are exposed to the danger zone. I'm at the end of today's webinar, and I am very happy and I'm glad that you joined us today. And I thank you very, very much for being our guest today. I just see in the chat function that many questions just are arriving as now. So I will give you a few more minutes. If you want to leave your questions or comment, please use the chat function. We will definitely get back to you and answer your questions or your comments. There are different ways to connect with us. You can either write us a letter if you want, or use the email or the telephone. You can reach our whole Power Quality Mobile team under this number. You can write us an email. You can go to our website, and we can if you will need support with your product or measurement files, we can always help you via telephone or via Microsoft Teams, or we can also, you can share your screen with the TeamViewer application we included in PQ-Mobil, for example. So you simply, one more time, I change to PQ-Mobil. You can go on the help button, the totally underestimated help button, and click on remote assistance via TeamViewer. Then, as long as you have internet connection and the IT security allows this application, it will show you an ID and a password, and you can share this ID and password with us on the telephone, for example, and then we can have a look on your measurement data live and investigate the problem with you. So thank you very much again for being our guest today, and I hope we will see each other next time. Take care and bye.